Okay, so the important things you need to know about this chapter, and we are doing new number patterns, is that the first thing is that the general term is expressed as the nth term and is written as Tn, meaning in this form, Tn, like that. And this is the nth term, okay? And we define the common difference D of a sequence as the difference between any two successive terms where D is equals to the Tn minus the Tn, the term which is one before it. So n minus 1, the one before it. N minus 1 means the one before it. So basically, if I can rewrite this, this would look like this, because when I typed it, it didn't come out quite nicely, is that it would be the common difference is the Tnth minus Tnth minus 1, right? And this would mean the term before the term that you have chosen. So if it was the second term, then it's 2 minus 1, so it would be the first term. If it was the third term, then it would be the second term, and so on and so forth. And that is the common difference, right, which is your D. And we can work out a general formula for each number pattern. You use it to determine any term in the pattern. So if we have a general formula, then we can work out anything in the pattern, right? And that's the entire point about this particular chapter, right? But now let's get into what we're actually looking at. What type of number pattern is the focus on this year, right? So what type of number pattern are you looking at this year? So the pattern we are looking at is called a linear pattern, right? And a linear pattern, what it basically is, and if we had to think about it, why would they call it a linear pattern? It's because in actual fact, if you had to have created a graphical representation where maybe we would signify the vertical line as your y and your x, in actual fact, it does move it, or it does, you would draw it as almost like a straight line. But the difference is that this straight line will always start from the positive numbers going, positive x numbers going that way, right? And never to the negative numbers. Why is that? It's because obviously it is natural numbers, and we're looking at natural numbers. But what is the consequence when I say we have natural numbers? Think about this. We have a number line here. This is a number line going to the right hand side, and in between 2 and 3, you know that they are fractions and irrational numbers. But now you're not going to be looking at that. You're actually looking at the number that it gives you at this point here, and at that point there, and at that point there, and so on and so forth. So in actual fact, it would be dots that are following a straight line sort of form that forms a linear pattern. And a linear pattern's formula would be kind of similar in that way to the normal function formula of a straight line, right? So that is the difference, right? So in actual fact, when we talk about linear patterns to a linear graph, the difference is that a linear pattern gives you only one solution and not a full line like a function, but what it would give you is actually dotted dots that you can connect that would make a line, right? And it would only be in the first quadrant, right? This is the first quadrant, okay? So that's quite interesting. But the formula, as I'd shown you, it's Tn is equal to Dn plus C. How do we obtain this formula? So now you're given that the Tn is equals to Dn plus C. And basically this means that you will be given a particular sequence, and that sequence would follow that pattern. But how do you figure out whether it is this formula, right? Does it follow this formula? So just imagine now you have these variables, but these variables, it's d plus c, 2d plus c, and 3d plus c. So you could guess that the next one will be 4d plus c, and so on and so forth. So let's see the difference between the two consecutive terms or successive terms. Is that in actual fact, what is the difference between the two? And remember, when we talk about difference in mathematics, we're usually talking about the subtraction sign, right? We're usually talking about the subtraction sign. Therefore, what we would do is, so for the second and first term, to see the difference between the second and first term, what we would do is we would say the second term minus the first term, and we actually see when we simplify that, it actually gives us an answer D. But also again with the third and second term, you would find that when you do the calculation itself or the simplification itself, you'd find that it's also D again. And so this brings us to something that is quite interesting. But you notice something that is interesting about this result, that it's giving you D, is that in actual fact, for all the successive terms, each time you will take this one and subtract it with that one. This one you subtract it by the one before it. You take 4d plus c and you subtract it by 3d plus c, and so on and so forth. It should always give you a first difference that is d across, straight across. And that is why when we draw these lines going down, we are actually signifying that we are taking 2d plus c subtracted by d plus c. And for this one here, then it's 3d plus c minus 2d plus c, and that gives us d. And we know now that in actual fact, it is a linear pattern because it has a first difference that is constant. So therefore, when we have a constant or common first difference, now you will hear in some cases where they will say it's common or it's constant first difference. When you have a common or first difference, so if you have a constant first difference, without a shadow of a doubt, we have a linear pattern because of that, because we have a common first difference where this is equals to that and that is equals to that and so on and so forth. That means that it definitely sure we know that it is a linear pattern. And that's when you know that you can start using this formula here. But recall the formula that it says T of n, or the term number, is equals to D, which is the first difference, times the term plus C. And this C, how do we get this C? Now, in actual fact, it's actually very easy once you get your common difference. After you've gotten your common difference, it's actually very easy because you can notice that in actual fact, the Tnth is the value of an nth term, and D is the first difference, and N is the term or the nth term that you have chosen. So which Tn and D and N are given? So when you have Tn, D and N, right, which is the nth term here, right, and when you know all three of these, especially once you know the first difference, then the only thing you need to do is actually you substitute the values of these three things, and then you just solve for C, sorry. So you solve for C. So the result will be in the form of Tn is equals to Dn plus C. And that is quite interesting, right? So now you know how to determine whether it is a linear pattern, and you know how to get your C. So here's a quick example. So let's determine the general term of the pattern 5, 7, 9, 11. If you see the difference between 7 and 5 is 2, meaning that we said 7 minus 5 gave us 2, 9 minus 7 gave us 2, 11 minus 9 gave us 2. So that means that the common difference, or the common difference here is 2. Now here they used D, but it's still the same thing. You can just say it's D and D there. Okay, so it's still the same thing. So now you know that this is 2, so you'd substitute 2. So what you would say is I have Tn, but now I know my D, and that is 2, so it's N plus C, right? And then, as I said, the Tnth is actually the value that is on the series, the sequence. So for me, I'm going to randomly choose 9, and this is the third term. So then you know that in actual fact your n is the third term. So your tn is 3 there, and it's 2, 2, 3 plus c, right? And your third term is actually equals to 9. So it's 9 is equals to 2 times so 2 times 3 is 6, right? It's 6, and since we know that it's 6 plus c, then we solve for c. That c would mean that in actual fact we get 3, and that would be your c. And then you rewrite it again and say that your tnth, or your general formula, is 2n plus 3, and that would be how you get your general formula. And this general formula now can give you any particular value on this series, right? If they're looking for the 100th term, then you would have said the t of the 100th is equals to 2 times 100 plus 3, and that would give you 203. Okay, so that would be how you get the 100th term. So here again is the example. Here's another example where we have 8, 5, 2, and 1. So we get the difference, and we can see that the difference is -3. So now we have -3, and we know that it will follow this form because it has a first difference that is equals to each other. It is equals to each other. All these differences that we have, they are all equals to each other, and that is -3. So definitely we can use this formula. And once we start using this formula, we want to get c, right? So now what we do, you can select any nth term we know. It's tnth, right? So for me, I chose the fourth term. And the fourth term here is -1. This is the fourth term. So this is the fourth term. I chose the fourth term where the t of 4 is equals to -1. Therefore, when I substitute my stuff in or into the formula that we verify that we have to use it, is that we have -3 as your d, which is your first difference, and your n is 4, and then you have your t4, and that is -1, and then you substitute and you actually solve for c as you normally solve for x, right? And therefore you have your tn, which is -3n plus 11. But if you're not sure, this is something that's quite important. You can check by taking another term number that is obviously given with the ones that you can see, is that I took the second term, and then when I take the second term, -3 times 2 plus 11 will give me 5. And that is actually the case that I find for the second term, right? For the second term, I do have 5. So it is verified that in actual fact, my formula does work. So it's confirmed that we have the correct general formula, which is tn -3 plus 11. And so, as I've explained how we usually will do these things, I'd like for you guys to try out these problems that are here below. You can try them out on your own or with your study group, right? But please try them out, discuss them. You'll actually find them to be very interesting problems. Okay, so this is the first one. I'll scroll down very slowly, and once I've scrolled down very slowly, I'll end the video. So you'd write down the problem and stop the video wherever you have not seen, and then after that you do the problem. And if you have any problems, again, please do not be afraid to ask the person who is helping you so that you can get help. And if that doesn't work, you can also ask myself. But other than that, I really thank you for watching these videos, and I wish you the very best. Thank you and good luck.